Okay, we're going to finish up material with counting principles. Okay, this is kind of extending our probability unit. We kind of talked a little bit about this during our probability unit, but we didn't go in depth enough. We kind of just said, well, let's not get into things more complicated. Let's just go straight to simulations and we can simulate probabilities. Well, we're going to go back because it's very important. If you do take statistics in college, they definitely require you to know these counting principles. Okay? So it's all about number of ways to select things. And today is all about the basic counting principle and a little bit about if we do have things that can't be repeated, we'll do some problems like that. But the basic counting principle you already know, so this is review. We're just going to kind of have more problems on this than we've had in the past. Okay? So suppose the task involves a sequence of k choices, n being the number of ways the first stage or event can occur, and 2 being the number of ways the second stage event can occur. Continuing the way, we're going to let n sub k be the number of ways the kth stage or event can occur after the first k minus 1 stages. Then the total number of different ways the task can occur is just multiplying the first number of ways times the second number of ways times the third times the fourth until you get to the last one, which we'll say is the k. Okay, that's the key. That's the basic counting principle. Here's a great example. You've seen this and done this before. Just another, doing it another time. So we have a deli with a lunch special, consists of sandwich, soup, dessert, and drink for $5. They offer the following choices. A couple choices for sandwiches, a couple choices for soups, a couple for dessert, a couple for drinks. How many lunch specials are there total? Well, here's what you do. You use the basic counting principle. It's all about, I have 1, 2, 3, 4 events. You got to pick a sandwich, you got to pick a soup, you got to pick a dessert, you got to pick a drink. And you got to figure out how many choices for each spot there is. I always draw kind of lines. Typically the lines are not like underneath, but I'll say, okay, we got the sandwiches, we got the soup, we got the dessert, and we got the drink. It helps me realize that I have 4 things going on, or 4 spots to put choices into. Okay? And then what goes in the spots is not, the amount, the number, like cost of something. I'm not putting the cost of the sandwich, cost of soup. I'm putting the number of choices in each one. Choices go here, and this is the number of events. Well, I had 4 choices for the sandwich, 3 choices for the soup, 2 choices for the dessert, and 5 choices for the drink. Multiply those together, and you get the total number of lunch specials. And how many lunch specials do we have? 120. Thank you. Okay? Simple. If I'm taking a test that has 5 true-false questions, you can either answer true or false for each question. You can't leave any of them blank. How many ways can you answer the entire test? Well, there are 5 questions. I do 5 lines. 2, 3, 4, 5 for my 5 questions. The choices that I have for the first question are true or false. So I put 2 for my first question. Choices for my second question. 2, 2, 2, 2. Now, what's great is that since these choices are all the same, we can combine these and write it as a number to a power. So I have 2 choices 5 times. And 2, 4, 8, 16, 32. That'd be 32 total. All right? Another example. A company places a 6-symbol code on each unit of product. The code consists of 4 digits, the first of which is a number 5, followed by 2 letters, the first of which is not a vowel. How many different codes are possible? Okay, well, I start with my lines, which is my kind of events or, things that I'm going to place. I have 6-symbol code. So 1, 2, 3, 4, 5, 6 lines will be written down here. 1, 2, 3, 4, 5, 6. Okay, this will help me just keep organized. The code consists of 4 digits. So 1, 2, 3, 4 digits followed by 2 letters. Now, the first digit is the number 5. That does not mean I put the number 5 here. I have one choice for the first event. The one choice is the number 5. So instead of putting 5 here, I put the number 1 because that's the amount of choices I have for that one slot. One. Now, we have 3 other digits, which can be any number. Well, including 0, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total digits. Okay, sometimes we forget that 0 counts, and we think there's 9 digits, but there are 10 digits. So I have 10 digits possible that I can select for the second slot. I have 10 digits for the third slot, and 10 digits for the fourth slot.
Wait, the first one's number 5, right?
Because it's not that I have 5 choices. Telling me that there's the number 5 means I only have one choice for this first slot, and the choice is number 5. Okay? Now, we'll talk about this next, actually. Now, followed by 2 letters, the first of which is not a vowel. Okay, let's call the vowels A, E, I, O, U, and we will exclude Y. So only 5 vowels. That means if there's 26 letters in the alphabet, I have 21 choices for that slot, which means I have 26 choices, including the vowel, for the last slot. And that's how I would do that. Now, we could change this question a little bit to say letters or numbers cannot be repeated. Let's do that underneath. First, what is the amount here? This would be 546,000, so 546000. Great. Okay. Now, the question could be changed, and they could say, we have a 6-symbol code on each product, 4 digits followed by 2 letters. Same stipulations, the first number is 5, but they could say you cannot repeat a letter or a number. Okay? Now, the same process would hold. It's just you have to be cognizant of what amount of choices you could have. Okay? So the first number is still 5. Well, my next digit can't be a 5, but it can be any other number besides a 5. How many choices do I have for the second spot now if I can't repeat 5? 9. For my third digit, it can't be 5, and it can't be one of the number that's selected here. How many choices do I have remaining? 8. and then 7. Well, I have 21 choices still for my first letter because I'm not going to be repeating a letter because there's no letters beforehand. But what would be for my second letter? 25, right? Because I've chosen a letter here. I can't repeat that. There would be 25 here. Okay, this is all kind of review. We can do that calculation and we'd be good. $264,600. Okay, less than the previous one. Okay. Yes, it's in this packet. We should be able to finish it before the end of class and go over it before the end of class. All right, a state decides that all of their license plates should strictly have letters, but there should be a total of 10 letters, express the total possibilities for a license plate as a number to a power. In this situation, we have 10 spots, but it's almost like, oh, I know what's going to happen. I have 26 letters for the first one, 26 for the second one, 26 for the third. Keeps going 10 times. So I have 26 being multiplied by itself 10 times. Okay? You guys do 1A, 1B to start. Go. We will go over 1A and 1B. Then you'll do 1C and 1D, and we'll go over those as well. Go ahead and check your answers for 1A and 1B with a neighbor. All right. Ms. Bushman, what do we get for 1A? This should be Bushman? Yeah, Bushman. That's what I said. That's supposed to be Bushman? Bushman and Bushman.
It sounds the exact same.
Okay, Bushman. I feel like I'm very clear, but I feel like you guys are... I thought that I was saying one of your names wrong, but no. Okay, good.
I got 24.
24, and how'd you get 24?
I multiplied 2 and 2.
Good. All right, Miss Pushman. Yeah. What'd you get for 1B? And how'd you get that? Good. Okay. 1C and 1D, go. Now for 1C, you're not going to have the same student speak multiple times. Okay? Well, that means the same student could speak multiple times. Yep. Let's say it's us 5 here.
Well, there's only...
Miss Adams goes first, and then We choose you, then you, then you, then you. You're 5. You're one of the 5.
So what about?
Yes. Miss Mann's got the right idea. If people around Miss Mann
Not
want to help.
looking at her, trying to figure something out.
What? Mr. Englander.
I was thinking that. Does that make sense?
Yes, you got it. Good.
Well, I don't know.
All right. Because then you take that person out and put them back in and then choose from the 5 again. That means you could choose, you could speak every time. You could be first, and then, right. It's just like once you go, we're not going to choose from you anymore. Okay? So 6 students, 1, 2, 3, 4, 5, 6. We only have one selection. Some go-getter wants to speak first. Maybe he or she is nervous and just wants to get it out of the way. Maybe he or she really likes their speech. I don't know. That means for the second speaker, we only have 5 people left. Well, once the second speaker goes, he's not going to speak again. So that gives us 4 people left for the third, then 3 for the fourth, and then 2, then 1. Okay? And how many total is that? 120. All right, 1D, have we done that yet?
Characters or characters?
Characters would be letters.
No.
No, just 5 events, 5 slots. There's 5 slots. First 3 are letters, last 2 are numbers. The first letter must be one of these.
Okay.
Does this mean from like when it means numbers, like how many?
So numbers are, digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
There's just
So
10.
there's 10.
Okay. So it's basically 11 times 0.
Yep, that's perfect. Miss Martinez has the right idea. Yes. Good. No. Mr. Riley will help you. The 10 digits here, 10 digits there. That's right. How many possible choices do you have for the first one? Then for the second one, then for the third one, then for the fourth, then for the fifth. Okay, you just got to figure it out. Good. Sure. All right, Mr. Riley, what did you get and how did you get it?
You can only have 6 letters, or 6 letters for the first one.
Exactly.
You have 6, and then you can use repetition of characters. So you got 26 for the next 2.
Yep.
And then 0 through 9 is 10 for last.
That's it. 6 P, W, Q, E, L, or K is for the first one. 26 letters can be used for the second one. We don't care if we use P again. 26 letters can be used for the third one, and then 10 digits, 10 digits. Okay, I'm going to go and set you free for your homework. However, there's a couple challenge problems that I want us to do first before I set you free. What do you mean? This is it's really short. You're going to be okay. You're not, guess what, Mr. Englander? You're not going to have homework. Because you're going to do it in class. School's not over yet.
Just show me your problem.
I'm going to pick on Mr. Englander for the rest of this unit.
I'm pretty checked out.
Okay, number 10. Go. Let's see if you can get number 10.
I thought we were doing all of them.
We are going to do all of them, but we're going to do the hard ones first together.
Oh, we're doing
No. No. Because it's not Joe here, and it's not Susie here. It's just a boy here and a girl there.
So it would be 2 and 2?
No. 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 8 seats. We know there's 8 seats, so at least start with 8 seats. 1, 2, 3, 4, 5, 6, 7, 8.
3 and 5?
Yes. Nope. Definitely not one way to do it. Good.
I'm nervous. What if I did it wrong?
It's wrong. Yeah.
Why? Doesn't that make sense?
Well, you could put the same boy in every seat, which doesn't make sense at all.
Yeah, but there's already someone there, so... Oh, you'd have to... Oh, no, I'm wrong.
Yeah, you're wrong. Then you could put the same person in every one of the 6 choices. Miss Pushman, have you finished it? Oh, good job. Miss Pushman's got the right idea.
Same person in every seat?
No, you can't put the same person in every seat. That's right.
Oh, okay.
You fixed it.
Okay.
No. Good. Close. That's good. The middle's wrong. Not all 6s, because then you can repeat the same person. Yep.
Because you add the 2 together, it doesn't matter.
Yep, that's right. No. Put your phone away. Especially if you don't understand it.
And it can't be the same number. So it's 5, 4, 3.
All right, ready?
Wait.
Nope. All right, here we go. This is why we're doing this, because this is a tough one. The key to this is to figure out the first seat and the last seat first. Okay? Well, there has to be a boy in the first seat. Well, I'm not going to put 1 because there isn't just one boy that I can choose from. There are 3 boys. I can put any of those 3 in the first seat. So I have 3 possibilities for that first seat. Now, the last seat has to be a girl. Well, there isn't just one girl, so I'm not just going to put 1 here. I have 5 girls to choose from, which is why there needs to be 5 choices there. Now, I've picked a boy and I've picked a girl. How many choices do I have left? 6 choices. Now, after I pick that person, I'll have 5 choices. After I pick that person, I'll have 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. And what did, and, I don't know. I know, I hope it's storm. Free water. Free water.
Do you collect the rainwater?
No, but for my grass. What do we get for this? 10,800. Okay, good. So that one was tough. Let's do another one that's tough. They're not all tough. Number 15 is similar. Do number 15.
I'm sorry, let me...
Gosh. You guys should get My Radar app.
What is it?
It's just to quickly, have I?
Really happening?
So we're getting something, we're getting a little bit, but not much. Yeah, it's old. I think it's a 5, actually.
Okay, well, it looks like it's going to be coming right over.
It's not to hit us pretty hard, but it's not very large. Maybe a transformer will blow and the lights will go out again.
Maybe not. Did I do this right?
No. Do number 15. Do number 15. I haven't seen anybody do it right yet. That's right. Dictionary is a book. Well, there's one there, and you're saying you have 6 books to choose from the first one, but we only start out with 6. One of them's a dictionary, one of them's at the end. Yep. No. That's it. Good. All right.
Did I do that right?
Just thinking about the end result.
Mr. Meyer, how do we do this problem? Can you tell anybody? No? No. All right. Watt, tell us how we do this.
Okay, so the last one has to be 1.
Why is the last one 1?
Dictionary.
Because it's a dictionary, and only one of the books is a dictionary.
That's just what I originally did, and then I read.
See, it doesn't say old. It doesn't say old. It says on and then. At least it says on and then. So
Yeah, that's what I got hung up on.
Yeah.
And
on and then. It doesn't say on the end. On and then.
Oh, that does make things different.
That's why. I think I got it right.
I did like 5 minutes to 1 point, and then I reread it.
I don't think.
All right, change it to on the end. No. All right, now if it reads on the end, what you put the dictionary on the end, what do you do for the other slot?
You go 5, 4, 3.
Right, that means there's 5 remaining books there, then 4, then 3, then 2, then 1. No, you didn't. You had 6, Miss Adams. Number 16 is also a difficult one. Let's see if we can do that one. And then you guys can do all the others by yourselves. Well, I'm going to check randomly on students after a certain amount of time to see that they've all done it. And by the randomly, I mean I'm going to come around and see who hasn't been working, and I'm going to pick on you.
Go ahead.
Yes. No.
No. Well, that's what I said.
You have 2 options for one of them. The other one has to be the other one. 10 spots. 2 people are getting booted.
Alright, okay. Or why?
Close. That's wrong.
Is it 1?
Yes. The answer,
Look, I know I have it. Look.
I'm going to tell you the numerical answer. I'm not going to tell you how I got it, okay? $3,628,800.
3,628,800. Okay.
Check it out, dog.
Yeah, you got it. Good.
I messed it up by one.
Good. Got it.
Wait, what'd you say? What was your answer?
Nope. It's close.
What do you mean not right?
Nope.
Wait, what was your answer?
3 million?
I got
7 million.
Yeah, but that's too many spots. 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh.
3,628,600.
Okay, I changed what you told me to change, and this is what I got.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What happened to 8? 10, 9 to 7?
No, went away.
Yep. You got it.
Oh, that is
Yep, that's right. You pick X and Y here. That means we go from 12, 11, 10 people for that first spot. 3,628,600. That's a big miss. Nope, close. That's wrong. Yep. Yep, 3,628,600. Okay, raise your hand if you got 3,628,600. 800. Sorry, 800. Oh, so you got it? Good. All right, Mr. Meyer, walk us through it. You don't know? It actually ends up working out. All right, Miss Burke, walk us through how you did it.
I multiplied 10 by 9 by 2 by 1.
All right, how'd you get 2 and 1 here?
Because it said, student X or Y has to be in the third position, so the third position, it could be student X or Y, but then the fourth position, it can only be one of them.
Right. X or Y for the third, and then it's the other one, whichever one you didn't select for the third one is the fourth one. Okay. And then how many spots for the fifth? 8. Good. And then it resumes 8, 7, 6, 5, 4, 3, which ends up just being 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. Okay. But it's good that you guys wrote it out like this so that you understand exactly how to do it. Okay. The rest should be good. Okay. Go.